Hello, welcome to the third episode of our series, the third episode of SolTouch. Today we're going to talk about the vastly popular subject, namely the NFTs or non-fungible tokens. NFTs are tokens that are unique. So basically, tokens issued by a contract, by an NFT contract, are unique. There are two popular standards of tokens in Solidity. It's ERC721 and ERC1155. The difference between ERC721 and ERC1155 is that in the first one, each token is unique, and there can be only one instance of each type of token issued. In the ERC 1155, each token may have multiple instances, but nevertheless there can be infinitely many different tokens in the ERC 1155 contract. Today we're gonna talk mostly about ERC 721, and we're going to attempt to build our own collectibles. So basically we're gonna try to see how a collection is created, how some different images, for example, can be tokenized. So I created these two images, original collectible and elf, which will design an NFT for. So at the end of this video, each of these pictures will be basically backed up by an NFT. And yeah, we'll go through the ERC 721 standard, the one from Open Zeppelin, and we're gonna see what we can do with such a contract and implement our own collectible contract. First of all, we need to know about enumerable maps and enumerable sets. An enumerable map is basically a Solidity mapping. For example, this could have been something like this. But the difference is that in an enumerable map, we also have a length function, which we're mainly interested in this contract. So basically, we know the number of mappings in the contract. The same goes for enumerable sets. We have a set of holder tokens in our case, and we also know for enumerable set the length of the elements in the set. We're gonna pass through the functions in this contract one by one, and I'm gonna try to explain them to you. So first of all, in the constructor, we have the name and the symbol of the contract, of the collection, if you will, and we're registering some interfaces so that external contracts know what our contract is able to do and process. I won't go into detail, but I'll explain later in this episode why having registered interfaces might be important. Balance of, as opposed to an ERC20 balance of, is provided with an address and returns the number of all different NFTs owned by that specific address. Owner of refers to the owner of a specific token. So in the ERC 721, each token is unique and each token has a specific ID, which is sent as a parameter in this owner of function. So basically the function owner of is called with token ID, and it returns the address that owns that specific NFT. The name and the symbol are the name and the symbol of the collection, of the contract. Each token in an ERC721 ERC721 has a URL. So basically, when you issue a new token, it's preferably to also bind the URL to it. In our case, the URL will be the URL in which at which this picture can be found, or this picture. So this function returns the URL of a specific token. Base URL is used when, for example, if you have a website and you create a smart contract for a specific collection, but you only want the resources, the photos, the official ones, to reside inside your website, you can, for example, define a URL, a base URL, something like this in our case. This will mean that for each collectible we can define only this part of the URL, and by default, when we request the token URL, we will receive the base URL concatenated with the second part, which will be the token specific URL. So in our example, if we want to do this and have a base URL, the second part will only be original collectible.png, and the final URL will be still this one, but the authors, which mint the tokens, won't be able to define an outside URL. Okay, each token minted is minted and owned by a specific address. So if one address owns two tokens, then with this function we can query a specific token of those two. We send the owner address and the index. So for example, if the owner address owns two tokens, we can query token number 0 or token number 1, and we'll receive the token ID of that specific NFT. The total supply simply returns the number of tokens issued by the contract. Token by index basically returns the token ID for one token at a specific index. Each token in the contract has an index. So for example, if I add 10 tokens in the contract, doesn't matter who owns them, there will be 10 indexes from 0 to 9, and one will be corresponding to a specific ID of each token. The approve function allows an address to approve the spending of a particular token he owns. For example, if I own a token with ID number 1 and I want my friend to be able to transfer this token on my behalf, I can approve. I can call the approve function with his address and the token ID that I want to allow him to spend. Get approved simply returns the token approval of a specific token. This will return an address which is allowed to transfer that specific token. Set approval for all and is approved for all gives access to a particular address or operator to spend or transfer all of the tokens I own. Transfer from transfers a token from an address to another address. It's called with the from address, with the to address, and the token ID that I want to transfer from one to another. And of course, I need the approval before I can do this. The safe transfer from and the same function with one more parameter does an extra check, and we'll see what this extra check refers to when we look into this function. So this function also calls the check on ERC721 receive, which is this function right here. Now, what this function does is to check if the receiver is a smart contract or not. If the receiver is not a smart contract, then everything is fine and the transfer can be initiated. If a receiver is a smart contract, it looks if that specific receiver implements this interface. So basically this is useful because if you want to send a token to another smart contract, you might want to check if that specific smart contract knows how to handle NFTs. So if you send it to a contract that doesn't have this interface implemented, chances are that the contract might not know what to do with that NFT, so might not have functions that are able to further transfer the NFT, and it might be blocked on the contract forever. So we might want to use a safe transfer from function if we're sending tokens, especially if we're sending tokens to smart contracts. Okay, where were we? Exists function simply looks if a specific token ID exists in our contract. Is approved or owner checks if you're the owner of that specific token or if you have approval to spend it. Safe mint creates a new token with a specific ID and possibly with some data attached to that specific token. They both call the mint function eventually, which is this function here. It's better to call the safe mint because the safe mint also checks if we're minting a token into a smart contract that might not have the ERC721 receiver implemented, and if that's the case, it reverts the transfer. We also have a burn function to remove a token from circulation, a transfer function which transfers the token from an address to another, and it's an internal function of the contract. We have the set token URL. So basically this sets URL for a specific token. It's an internal function, so we'll have to handle the logic. It doesn't happen by default in the mint function. You can also set the base URL. For example, we could do this in our constructor, in the constructor of our future contract. We talked about this function already. Approve function, the internal, the private approve function is what ultimately gets called in all other approve functions, and this is a hook that you may want to overwrite when a token is transferred from one address to another. Cool, so now we went through the essential parts of the ERC721 contract, and we want to build our own collections. What we want to do is have an owner to this contract which will whitelist authors to mint their own tokens. So for example, you can imagine a use case like this. You create a smart contract and you have a website where different artists can upload their digital art and can issue an NFT for each of them. So what we want to achieve with this contract is have the infrastructure which allows us to whitelist some authors, some addresses that can mint NFT for their digital art, and allow them to also create this kind of tokens. So first of all, we would like in the constructor we're first of all calling the constructor of the ERC721, and then we'd like to add the first original collectible directly in the contract's constructor. So in order to do this, we need to mint a token. We're gonna use safe mint just for good practice, and safe mint function is called with an address on which we want to mint the token and token ID. So we're gonna mint the first token on the deployer of the contract, and we're gonna give it ID number 0. Then what we want to do is to set the token URL, and for that we're gonna have to specify the token ID. We want to do this for token ID number 0, and we're gonna take this URL and specify it here. Then we want to have authors in our contract. So in order to have authors, we need a sort of a whitelisting system, and this can be done in the most basic case with a simple mapping which points addresses to booleans and is named is author. So here we want to also declare the owner as an author. What we need to do for this is the following line of code. Okay, now we have a constructor in which we mint the first NFT. We're the owners of this NFT. The deployer of the contract is the owner of this NFT, and we're gonna set the this URL for that NFT. Also, we're gonna name ourselves authors of this contract. We'll need a modifier that can check whether or not the one who calls the function is an author. So in order to do this, we're gonna have to require that the message sender is an author. And we're gonna throw this message in case the one who calls the functions which have this modifier is not an author of the contract. Now we need the owner to be able to add his authors. So in order to do that, we're going to declare a function add author, and the author will be a specific address. This is gonna be an external function, and the function called by the owner of the contract. We can use this modifier because we inherited the ownable contract here. So what the ownable contract does is creates the basic functionality for having an owner and having a modifier that checks whether or not the caller of the function is the owner of the contract. So now that we did that, we're gonna declare the new author as an author of the contract. Now we would need a function that removes the author, because you might want to remove this privilege of being an author to a specific user that, for example, abuses the system or creates too many NFTs or doesn't comply with the rules of your marketplace or website or whatever. So you will need a function like this which removes him from the owner array, from the owner mapping. It's still an external function called only by the owner, and what it does is it sets the mapping of the old author to false. So once the function is called, the user is no longer an author of the contract, and right now we have the functionality of adding and removing owners. We have one token created in the constructor, but we will need the authors to be able to mint their tokens. So we're going to create a function mint token, which will be called with a URL. Can be called externally and only by the authors of the contract. So basically we're gonna attach this modifier to this specific function, and by the way, this underline here specifies where should the code from the function at which we attach the modifier be executed. So we could do something like this. It's the same thing in our case, but it's safer to have requires before you execute any code of the function. Okay, so we need to do a safe mint, and we need to pass an address and the token ID. So as an address, we're gonna use the message sender, because we want to mint the token on his specific address. And for the token ID, we need to generate a unique token ID that cannot be found minted already to any of the existing owners. So in order to do that, we can, for example, use variable token ID, which will be equal to the total supply of the contract. Total supply. So the total supply basically returns the length of the token owners mapping. So in our case, after we call the constructor, the first time we call the mint function, the total supply will be 1. So the token ID will be 1 in our case. The second time we'll call the mint token function, the token ID will be 2, and then 3, and so on and so forth. We now need to attach a URL to the token we've created, and the URL luckily is provided as a variable in the function that is called by the author, and the token ID is basically the token that we've just created. Good. So now we have a function that creates token ID tokens and sets them URL. So next thing is to actually deploy this on the testnet, and we're gonna do this by running truffle migrate and specify the network Rinkaby as our targeted network, and this will compile the contract and tell us if everything is okay with it, and if yes, it will deploy it on the testnet. Don't worry about warnings such as license warnings, they're not influencing the contract in any way. Some libraries have the constructor visibility specified, and the solc might throw a warning for that. This isn't an issue with our contract. It just says that it simply ignores it, and in the case we want it not to be callable, we can make the whole contract abstract. Then a dry run of our deployment is simulated, and the initial migrations should be executed. Let's check if everything is in order here. So we have the name of our contract, and the contract instance, and the SolTouch collectible, which is the name and the symbol of the contract. Something went wrong here. We received some timeout, some reason. I will just run the deployment command again and hope we don't get into trouble again. Okay, so it seems we have a little trouble, which doesn't have anything to do with our contract not compiling. It has to do with the network, and it throws a timeout in dry run. That's an interesting error. Let's search for this on Google. It might be something related to Infura, which we're using in the truffle config. So probably if it fails again, it might help to put here a different Infura link. But let's try it again and see if we really need to do that. Okay, so I'll pause the video here, get a new Infura link, and try to launch with the Infura link again. Okay, so we're back. I've changed the Infura link and migrate the contract again, and it seemed to work. So probably there are occasional issues from Infura, but if is the case that your contract compiles and then you receive an error in initial migrations, that's probably an issue of connecting to the network. So you can simply try to change the Infura link or simply use other provider. Good, so our contract deployed to this specific address. We're gonna run this command to automatically verify the contract on EtherScan. So the EtherScan can build that nice interface from which we can interact with the newly deployed contract, and it will provide us a link. We'll access that link, and in the browser we're gonna navigate and play a little bit with the contract that we've just deployed. Pending. Usually it doesn't take this long. There are probably some slow internet connection issues on my side. Okay, so it verified. We got the link to the contract, so we can access it on EtherScan, and here we got the compiled code and also the interface from which we can interact with the contract. So first of all, we would like to see the number of tokens, and it's 1, so basically just the token that we placed in the constructor is issued. We can get the token ID by index, but in our case and in the way that we've built the contract, it will always be equal to the index that we place here. Then we can check who the owner of this contract is. Okay, so it's this address, and I have it here in MetaMask, so we're the owner. Then we would like to check the URL of this specific token, so we'll query it by ID, and we receive the URL, so we can verify that it's this address. Okay, And now what we want to do is to add another author to the contract. So basically we're gonna have to go here, connect with our MetaMask. We're also the owner of the contract, so we can add authors. And I want to add as an author the second address in my MetaMask. So is author number 1. Hold on. Ethers can throw this error if you change the account while connected to one of them. Okay, so I added this author to our contract. Now he has the right to also mint tokens. So we can go here. We can connect with that second address. We're connected with the new created author, and we can mint our token. So basically, let's say that I've uploaded my digital art and I simply want to issue and mint the NFT behind it. So I will provide the URL to that function, and it will automatically mint my NFT with ID 1. So if I go here to read contract, when this transaction is done, the total supply should increase. So it's instead of 1, it's going to be 2. So it already increased. And then we can check the token URL of the token with ID 1. We can check who's the owner of the token with ID 1, and this is my new author address. And basically right now we have a contract that has 2 authors. Each of them has 1 specific tokens, and each of them can add more tokens. Now with these tokens, we can transfer them from one user to another. We can implement something more sophisticated in the contract, for example, like a bidding system. I won't go through this kind of stuff in this episode, but I hope I covered the basics, and that is to mint ERC721 tokens, to have a URL for each of them, and in case you want to create now a collection of some sorts and maybe sell some collectibles or have some collectibles and share them with your friends, with a simple contract like this, you'll now be able to actually create a collection or create collectibles and do whatever you want to do with them on the blockchain. So thank you for watching, and I hope it was helpful. Next time we're gonna go a little bit through ERC1155 and see how we can have more types of tokens in the same contract, but not limiting them to only one instance. Thank you, and see you next time.